Hello guys, so today we are here to solve this problem called short colors. This problem is actually called Dutch national flag problem. In this problem, we are given three integers, 0, 1, and 2. So these three integers represent the colors of the Dutch national flag. Um, there are only three colors in Dutch national flag. They are red, white, and blue. So we need to sort this, the content of this array, which can contain only three elements, not more than three elements, to all zeros should come before all ones should come before all twos. So how to do this? So basically, we want to segregate this array in three parts. And how can we, sort this array? So one very common technique which comes to mind is, just take this nums dot length, okay, and then let's say one count, uh, one count, zero count, okay, and then two count. So these are three variables, and we initialize them to zero initially because initial values of counts are zero. So it makes sense to initialize them with zero. And now what we'll do that, we'll make a pass through this array and check whether it is equal to one. So if I is equal to 1, then it is, obviously we have to increment O count. Okay. Else if, else if I is equal to 2, then we have to increment Z count. So I think, if we consider only these two, then it suffices for us. And then afterwards, what we'll do, that we'll take the indexes of the array like this, and then we will do if one count is greater than 0, then we will do nums of I, is equal to 0. No, Z count is 0. Sorry, we have to write 0 over here. And then we will write Z count, 0 count, and then we'll take 1, and this will be O count. And then if Z count is greater than 0, then we'll take this, and then we will decrement like this. Else if one count is greater than 0, we will take nums of I is equal to 0 minus O count like this. And afterwards, everything will be nums of I would be equal to 2. So, and that will solve the problem for us. So let me run this. O count. So we have to implement this account. Okay. So some mistake is there. One. Yeah. So if we have taken this as, then we have to go till equal to n. Perfect. Perfect. See, in this problem, we are making two passes through this solution. One pass is this, and the second pass is this loop. So in these two loops, we are taking two passes through this nums array. Can we do this problem with one pass only? Is it possible for us to do? So to do that, what we will do that, we will use the Dutch national flag algorithm. And in that Dutch national flag algorithm, we have low is equal to 0, mid is also equal to 0, but high will be equal to, you know, high will be equal to n, and we'll get rid of this. Okay. So see, we are given an array. So let me draw an array first. So we are given an array, and in this array, the mid will be, going through the contents of this array. Okay. So this array is there, and one pointer called mid will be going through all the contents of this array. So it will start from here and it will go till this point. So low will be, at this 0, and mid also will be starting from this same place, mid, but high is pointing to this location. So high is pointing to this location. Okay. So when high is pointing to this location, it means when high is pointing to this location, it means since we are traversing this array through the mid pointer, then mid has to go from 0, that is at the position at which is equal to low, and then it has to go till the position high. So in order to do that, we have to run a loop, and that loop has to, go through all the elements of this array. In order to do that, that while loop has to run like this. While loop has to run like this. While low is less than, while mid is less than equal to high, because you know it is possible that our array contains only zeros and ones. It is possible. Okay. This problem, nowhere it says that 0 1 0. Nowhere it says that 2 has to be mandatorily there in the array. So suppose high point is pointing to some 0 value, and if we have the condition mid is less than high, then we will not be reaching to the high point. We'll always be going below that. But we need to process the 0th element which is at the last index. So that's why we have to have mid is less than equal to high. And after this, what we will do, that we will check if nums of mid is we can say that if less than equal to 1. Okay. My approach is like this, and then else part we will be doing swap of nums mid and high. Okay. And then we'll be decrementing high. In this case, there are two subcases. If nums of mid is equal to 0, it means that I have to swap the mid with the low value, and since low has to point to the next slot where 0 can go, so I have to increment the low. And I have to, and according to the invariants of this problem, values between 0 to mid minus 1 index at any point during the execution of this algorithm, values between 0 to mid minus 1 index. Okay, let me write this one. Okay, values between 0 till mid minus 1 index. Values between 0 and mid minus 1 index. These values will always be containing either 0 or 1. So whenever mid is coming across as, encountering a 0, nums of mid is encountering a 0, then we have to swap that with the low, and anything in between 0 and mid is, either 0 or 1. So, you know, we have to increment our, you know, we have to increment our mid. Okay. Okay. So we have to increment our mid. So we'll do plus plus mid. Okay. And then there will be another case in this, else nums of mid is equal to 1. So we need not, say, explicitly write this. We can just say mid plus plus mid. Okay. So this will take care of that. So only thing now remains is that we should be writing this, logic for the swap, which is easy to do. So we'll take this private void swap and array nums and I and j and temp is equal to nums of I, nums of I, nums of j, nums of j, temp. And then we will just, run this. We'll submit this. So I hope it is clear to you. Only thing is, the question that can be asked in during interviews is, that why in this case, we are only doing minus minus high, but in this case, when we are doing a swap, we are incrementing the low as well as mid. So the reason for this is, for that only, I have taken this as one part and this as another part. So whenever, mid is the boundary line after which or below which all zeros and ones have to lie. So once we are swapping mid, which is, nums of mid, where mid, which is pointing to 0 with low, then we have to increment low, because low now has to point to a new index where 0 will come. Next 0 will come. Okay. And since mid has to be incremented, so if it is nums of mid is 0, then we are swapping, then that new value which is coming under mid is now 1. So for that reason, so this mid is now pointing to, we can safely say that, this mid is pointing to a 1. And that's why we have to increment this. That's why we have to increment this mid in all cases. Okay. And here also, see, this condition is nums is equal to 0, and this else will be if nums of mid is equal to 1. And if it is equal to 1, then we have to increment the mid. So for that same reason, we are incrementing mid here as well. Okay. So these two, the increments of these two places where mid is being incremented is being done for the same reason. So I hope, with some little effort, you'll be able to see this. And this is an invariant of the problem. The invariant of this, problem is that, let me write it out. The invariant of Dutch national flag problem is between, so let me just write it out. The invariant of the Dutch national flag problem is between 0 and mid minus 1. Whatever is the value of mid during the process of the execution of this algorithm will only contain 0 and 1. Nothing else. 2 will not come in between 0 and mid during the execution of this algorithm at the beginning of this algorithm, or after this algorithm finishes. At that time also, in between 0 and mid minus 1, the only values allowed are 0 and 1. This is an invariant of the Dutch national flag algorithm. So if this is clear to you, you'll be able to go through this problem any point of time. You can easily explain, if nums of mid is equal to 0, then we have to increment low value also, we have to increment mid value also. If it is 1, if nums of mid is equal to 1, as is the case in this else block, then we have to increment the only the mid value we have to increment. So with this understanding, I hope things are very, very clear to one and all. And and for the same reason, when we are uh, doing this swap here, then we are decrementing the high, because high is pointing to the next location where 2 will go. So high is pointing to the position, the next location where 2 will go. Next location where next location where 2 will go, and low will be pointing to the next location where 0 will go. Next 0, where the next 0 will be placed, that is what low is pointing to. So with this, and same for mid will be pointing to the next index where the 1 will go. So please have a clear understanding of this. Then this algorithm is very simple, and you can easily write it down. So with this, I will stop this video. Let me know if you have any doubt. Please post it in the comments. Okay. So with this, I'll end this video. So this problem is about Dutch national flag, and people of Dutches and Dutchies are one of the most nicest people that I have come across. So this is my humble, this video is my humble present to the people of Netherlands. So with this, I'll close this video. Thanks a lot.